Today we're going to be discussing how to verify trig identities. Now this is my personal favorite lesson in all of math. So this is section 7.2 and it's called Verifying Trigonometric Identities. Some people call this proofs. Really what we're doing is we're showing how one side of an equation is equal to the other. So let me show you what this looks like. First thing we'll do is let's talk about our steps. So this is our toolbox. In our toolbox, generally, step number 1 is you pick the harder side to start with. And when we say harder side, it just means more complicated. So if you have like 2 trig functions on the left and 1 on the right, you obviously want to start with the left. Generally, what I recommend that people do is convert that side to sines and cosines. And remember your identities. We're going to use the reciprocal identities. And we're also going to use the Pythagorean identities and the quotient from last section. Really, the only Pythagorean identity we're going to be using over and over is sine squared plus cosine squared is 1. And we might have to modify this. I mean, we could always bring the cosine on the other side and say that sine squared is equal to 1 minus cosine squared, or we could bring the sine squared on the other side and say that cosine squared is equal to 1 minus sine squared. But when we get to those examples, we'll talk about it. And pretty much that's it. Most of the problems we could solve by doing those first 2 steps. Now, sometimes we might have to go a little bit more, and this is going to be a test of your algebra skills. You might have to factor, multiply, or let's just say use algebra. Something else you might need to do is you might have to get a common denominator. And there are multiple ways to do a problem. So, there's not only one way, one size fits all. So most of the problems we could solve using these first 2 steps. We might have to factor special cases. So you should remember the factoring formula for a difference of squares, where it's a plus b times a minus b. And if it's a cubic, which there's not many of these, but if there is, remember that we use SOAP, where it's a and b, a squared, ab, and b squared. And we're going to use the same sign, opposite, and always positive. If this was a negative sign, it would be the same, opposite, and always positive. So let's get into some problems and we'll see if we can figure this out. Let's start with something easy. Directions for the next few days are just going to tell you to simplify. And problem number 1, we have the cotangent of x over the cosecant of x, and that's going to equal cosine of x. So on a quiz, I might just ask you to simplify this, and the answer is going to be cosine, but in this case, I'm telling you that the answer is cosine, so let's pick the harder side. The left side is more difficult, and we're going to make that look like cosine. First step I would do is convert to sines and cosines. We know that cotangent is cosine over sine, and we know cosecant is 1 over sine. Well, we have a fraction over a fraction, so we can multiply by the reciprocal. The signs cancel, and we're actually just left with cosine. So we just showed that the left side converts over to the right. Let's try something else. How about so we'll say simplify, or we'll even say verify. How about an example that looks like this? That's secant squared of x minus tangent squared of x is equal to 1. Now let's convert. Secant is 1 over cosine squared. Tangent is sine squared over cosine squared. And we want to show that that's equal to 1. That's the more complicated side. There's already a common denominator, so we can combine these two fractions. And from here, we could, remember, we have to show that it's equal to 1. So if we have a cosine squared on the bottom, this looks a lot like the Pythagorean identity. Sine squared plus cosine squared is 1. What would 1 minus sine squared be? Cosine squared. And you could see, I just showed how the left side is equal to 1. We're just using different identities. This was reciprocal identity. This was a quotient identity. And over here we used a Pythagorean identity. We'll do one more. What if I asked you to show how tangent of x minus sine x cosine x over sine squared of x is equal to tangent of x? Now clearly the left side is more complicated, so let's convert that to sines and cosines. We'll have sine of x over cosine of x minus sine of x cosine of x, all divided by sine squared of x. Now I know that this looks a little bit like a mess, but let's just go step by step. Convert it to sines and cosines. Looks like we have two fractions on the top. Let's try to just get one fraction. What I could do is multiply this fraction by cosine over cosine. It's just like if you had 1/2 minus 1. How would you combine those fractions? You'd get a common denominator, which would be 2, multiply top and bottom by that to get a common denominator. If we multiply by cosine over cosine, we get sine of x over cosine of x minus sine of x cosine squared of x all over cosine of x. Now we have one fraction on top. And we're dividing by sine squared of x. Well, instead of saying divided by sine squared of x, let's multiply by the reciprocal. And now let's see what we could do. We could go ahead and multiply. I mean, we can multiply fractions. But really on top, I see a sine of x minus sine of x cosine squared of x. So this is an example where, like, let's say you had 2 minus 2x. I mean, one thing you could do is you could factor out a 2, right? That's what it would be in algebra. Using trigonometry, we could just factor out a sine. And we saw something like this in the last problem. Remember how when we saw, what was it? 1 minus sine squared of x over here. We used a Pythagorean identity. Well, we're going to be doing the same thing with this problem. I see a Pythagorean identity right here. 1 minus cosine squared. So if sine squared plus cosine squared is 1, what's 1 minus cosine squared? It's just sine squared. So watch what happens. These cancel, and you wind up with sine over cosine, which is tangent. And that's what we wanted to get all along. Now for these problems, I don't expect you to be able to do all this today. We're going to be spending, the next few lessons doing this. So if you get stuck, just, I do expect everyone to be able to convert to sines and cosines today. You should be able to use your identities and do that. But if you can't quite finish the problem, that's okay. We'll do one more problem. I'll show you something else here. What if I asked you to write as a single value of trig function? So this will be pretty easy. What if we had something like this, like tangent divided by cotangent equals 2. So what we could do here is, let me see here. Actually, I'm going to change the problem a little bit. Let's make it tangent of x and over secant of x. That's what we'll do. What we want to do is just get the left side to be one trig function. So this is pretty much like what we've been doing. So tan, remember, was sine over cosine. Secant is 1 over cosine. And when we get this, sine of x over cosine of x, we're dividing by 1 over cosine. So that's the same thing as multiplying by the reciprocal. And we'll get sine of x is equal to 2. All right, so just a little bit of a variation on what we've been doing. For homework, what I would like you to do is, let's see here, on page 367, please do numbers 16 to 22 even and number 30. All right, have a good time, and we'll talk soon.